Albert Einstein once said, "We cannot solve our problems with the same thinking we used when we created them." Hello, my friends. Welcome to episode number 527 of this here electronic engineering podcast called Amelia's Weekly Fish Fry, brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. What EE topic are we investigating this week? AI-driven verification. That's what. Please welcome Matt Graham from Cadence Design Systems. Matt and I are examining the what, why, and how of Cadence's new Verisium AI-driven verification platform. We investigate the different applications included in this platform and why this platform is a huge shift away from single-run, single-engine algorithms to algorithms that leverage big data and AI across multiple runs of multiple engines throughout the SoC verification lifecycle. So, without further ado, please welcome Matt to Fish Fry. Hi, Matt. Thank you so much for joining me.
Hey, Amelia. Thanks for having me.
Absolutely. So, Matt, we're talking about the Verisium AI-driven verification platform today. But, Matt, before we dig into the details, what was the motivation to create this platform? What challenges or issues is this platform looking to solve? And this is a big shift from a single run, single engine type of platform, right?
Yeah, absolutely. So the motivation is that our customers who are, developing microchips continue to expand the size just to meet the market need, right? The phone's always got to run faster. The computer's got to do better gaming. The AI at insert your favorite social network has to be better. And so as those chips grow, so does what we call the verification problem, which is basically, it's got to be right on the first try. And our customers need to make sure that what they're designing absolutely behaves functionally correct on the first try. And that problem has just grown to the point where it's difficult for an engineer or team of engineers to comprehend all the sort of permutations and combinations just in the pursuit of what is our current state. If it's not behaving the way I want it to, how do I get it to behave? How do I debug, when bugs pop up? And so we're kind of running out of steam on just let's make a processor a little bit faster so that Cadence's tools runs faster. We really need this kind of quantum shift, if you like, or paradigm shift to expand to include not just making one execution of one EDA tool run as fast and as well as it can, but to consider all the data across, many runs across many engines. Is there something from tool A that could be used by tool B to make tool B run better, faster, easier, whatever it is? And by doing so, can we build up some AI type capability to really give engineers the leg up? We're really, trying to provide the automated driving or autonomous driving for microchip verification and design in general. We're not quite there, but we're working on the, super cruise and the lane keep and the collision avoidance type tools.
I love it. That's a great analogy, Matt. Now, this platform includes a variety of applications, right? So can you give me some details about each of them?
Yeah, absolutely. So Verisium, as you mentioned, is a platform. It's not a single tool. It includes two kind of heavyweight apps that are the basis of the user interface for all the other sort of AI and ML niftiness that we do. Those two tools are Verisium Debug and Verisium Manager. Verisium Manager is kind of a regression management tool for our customers. So they're running thousands of tests. They're collecting all kinds of data, and it's a regression management data analysis type tool. What's running, what passed, what failed, what results did it have, and how can it gather those up and give useful statistics to the user? And Verisium Debug is we're running a whole bunch of tests. What happens when one of them fails? We need to go in and understand the details, kind of at the logic analyzer waveform level. What's going on where and when in the design, and all kinds of nifty tools that an integrated debug environment needs. And then there's, at least initially, and we think there's going to be a big sort of suite of apps. There's 4 primary apps that we've released for this initial version of Verisium. That is the wave miner, auto triage, pin down, and semantic diff. And they all have nifty little names, and I'll describe sort of briefly what each of them do. Auto triage is really about, if I have a whole bunch of tests that I ran, I have a bunch of them that failed, I need to understand of those tests that failed, which are the most important, which are the most critical that need my attention right away, and which can be put on the back burner a little bit, or maybe stuff we've seen before. And that's a task that engineers are doing regularly manually. And we're trying to automate that by building a machine learning model of what constitutes a really critical failure and what's less important. Then there's WaveMiner, which is using some AI to go look at the actual waveforms, so the traces of information coming out of passing and failing tests, to compare those together and then help the engineer get right down to the individual line of code, individual point in time that a bug occurred, so they can understand, very quickly what the root cause was. And again, that's to automate that process of narrowing down the view to like, this is what the real problem is. Here's where you can really focus your energy. Pin down is another tool that helps with that narrowing down of the problem. It actually integrates with the user's revision control system, something like Git or Perforce. The engineers are checking in new features or new interesting add-ons to their projects. And pin down, whenever we run a test, we'll go back through those check-ins and try and see, well, where was the problem introduced? If we have a test that used to pass and now it fails, we go backwards through that history and find that tipping point, right? What was introduced into the Git repository that caused a particular test to start failing and ultimately inserted the bug? And then lastly, semantic diff is something that is kind of a fundamental piece underneath those WaveMiner and pin down tools that does some intelligent diff of source. So when your engineers are developing source code, there's many kinds of changes they make. They might make real changes that change the behavior of their design, but they often add things like comments and white space and change the formatting or whatever. And what semantic diff does is go in and look at filtering out all those comments and other things, look at the source, understand how the source has changed in terms of its behavior, and then even rank those changes to behavior in order of sort of most disruptive to least disruptive. So it really helps an engineer understand where fundamentally or where behaviorally have the changes been made to my device since, say, the last revision or the revision before that.
So, Matt, Cadence has also released the JEDI platform. So how does Verisium work together with JEDI?
Well, so JEDI, since this is an audio format and you can't necessarily see how we spell it, is JEDAI, which stands for the Joint Enterprise Data and AI Platform, and pronounced JEDI. And what it does is provide a kind of cross-cadence data lake or centralized data repository, so that instead of storing, different types of data in different file formats on the disk, we're providing this kind of central database where all the different data across Cadence's wide array of tools, synthesis, simulation, emulation, analog, even, PCB design, all that data can be dumped in a single repository to then be recalled and can be cataloged so that today's waveforms are stored different than yesterday's waveforms and the day before that and the day before that. And because it's in a sort of central repository, it can be retrieved and searched and all those things that central repositories are good at doing. And that really helps all these tools, which we mentioned are multi-engine, multi-run. So, if WaveMiner needs to find today's waveform that shows the failing behavior and yesterday's waveform that shows the passing behavior, that can be done through sort of queries and intelligent searching of data rather than just, can you go find on the disk and try and remember which waveform file is from today, try and remember which one was from yesterday, and so on. We can really sort of organize, catalog all that data. And then we can build some sort of common AI capabilities across that, like being able to parse source code is something that, something like a semantic diff tool would need, but also maybe other Verisium apps that we're going to build are going to need. And so that all sits on top of JEDI as the sort of central repository of data that each of these Verisium apps can then pull from as it's trying to do something intelligent and interesting to really improve the overall throughput of our customers' verification flow. To give you another analogy, if Verisium is the painting, then JEDI is kind of the canvas.
Excellent. That makes sense. Matt, it's time for your off-the-cuff question. Now, I know that you just moved to Ireland. So tell me, what was your motivation to move there?
I've worked for Cadence for about 20 years now, and most of that time I've been working in my home office in Ottawa, Canada, where my family is from and where my wife and I have raised our kids so far. I have 3 teenagers, and we thought it was just time for sort of an exciting change. We've been talking about doing a kind of an exchange or relocation for a little while. Cadence is opening an office or has opened an office here in the city of Cork, which is in the southeast. And we just thought that'd be a great adventure. So I'm still with Cadence. I'm in my role related to Verisium and Verisium Manager. It's a cultural exchange. I guess I want to see if I can pick up another accent. Again, we're in audio format, so people can't see just how pale and fair I am. See if I can come to a place where I can find somebody just as pale and fair as I am. So just kind of an adventure. And so far, it's going great. Love it. It's super friendly people and a really cool place.
Excellent. I'm super jealous. I've always wanted to go to Ireland. That's wonderful.
You've got to come visit.
Yes, I do indeed. Well, Matt, I think that's all I have time for today. Thank you so much for joining me.
Thank you, Amelia, for having me.
If you want to check out even more Fish Fry interviews about artificial intelligence, I would encourage you to check out my playlist on YouTube called AI on Amelia's Weekly Fish Fry. In this series, I check out the largest AI processor ever made, neuromorphic computing, and how AI can predict the weather better than the weatherman. And you can check out this playlist by clicking the link below the player on this week's Fish Fryin' page, or you can also just head on over to youtube.com/eejournal and scroll down a bit, and there it'll be. Well, folks, that's all I've got for this week's episode because I'm a little under the weather this week. But don't worry, I'll be back in full force next week with an interview with RISC-V International CTO Mark Himmelstein. And the following week, I have an amazing interview all about IMEX advancements in microsurgery. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EE Journal. If you're into Twitter, you can monitor our tweets at EE Journal TFM. And don't forget, if you would like to follow my personal Twitter account, check out Amelia D 1978. And hey, if LinkedIn is more your thing, I dig it. You can follow us or me on LinkedIn as well. And we have a YouTube channel, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series hosted by me. And you can subscribe to our EE Journal YouTube channel as well. Also, by clicking the links below the player on this week's Fish Fryin' page, you can subscribe to this here podcast through Spotify, Podbean, or Apple Podcasts. And remember, if you'd like to further support this podcast, please leave me a review on that podcasting platform of your choice. Thank you, everyone, for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's Amelia, at eejournal.com, or post a comment on our forums on EE Journal. For the week of April 14th, 2023, I'm Amelia Dalton, and you've been fried.